Good day, I'm Dr. T, and welcome to my office. So you ever see a bottle labeled like that? Yeah, that's not a typo. That's actually a legit unit of concentration. Let's talk about normality. Okay, so normality. The short definition would be equivalence per liter, but that really needs some context. If you're thinking about a chemical reaction, what you'll quickly realize is that for some reactions, the actual identity of one or more of your reagents isn't specifically locked in stone. You can have some play as to which reagents you use. The classic case would be acid-base reactions. If you've got an acid and you're reacting with the base, quite often the acid disassociates once it's dissolved in an aqueous solution, at least mostly, and well, the proton's what's doing the reaction. The conjugate base just is a spectator ion. So if the conjugate base is just a spectator, it's not going to do any weird chemistry, and the pKa is sufficiently low enough that it gives up, all the relevant hydrogens, then it doesn't really matter which acid you use. You could use hydrochloric, acetic, sulfuric, phosphoric, or whatnot. Just, you need the protons. And you could have similar stories for oxidation reactions, reduction reactants. As long as they're able to give up or accept electrons, you're happy with them. Well, in this case, it's actually really helpful to be thinking not about the molarity of the chemical, the molecule as a whole, but the concentration of either the protons or the ability to donate or accept electrons or whatever active component of that molecule you're really thinking about when you're doing that reaction. So we have normality. This is going to be just like molarity, but it is multiplied by an equivalence factor, because different chemicals may very well be able to give off more or less protons. So let's look at hydrochloric acid. This is a monoprotic acid. For every one of these, they're going to be able to split apart and give you a proton. Sulfuric acid, this guy is a diprotic. It's going to split apart, give you a proton, and split apart and give you another proton. So you get twice as many protons per sulfuric acid molecule. This means that if I want, say, 1 molar protons, then I need 1 molar hydrochloric acid or half molar sulfuric acid. Because sulfuric acid gives me my 2 protons, what I can do is say, okay, well, I'll take the half molar sulfuric acid, I'll multiply it by an equivalence factor of 2, and boom, I've got normality, a fairly useful unit. We don't use it a ton anymore. This is one of those older units. If you imagine doing titrations, this would be incredibly helpful. But it is still one you see to this day, and it is still a common unit running around kind of in the background. So with that said, have a wonderful day and best of luck in the lab.